Good morning students. I am Ashima Chopra, your physics mentor for today's class. Okay, so today we will be learning about the most fascinating phenomena that light shows. But before dive into the main topic, let's recall what you already know about light. Okay, tell me, any phenomena that light shows? Anyone? Yes, light shows reflection. Very good. Okay, what is reflection, bachcho? Very good. The light bounces back when it falls on certain surface. That phenomena is known as reflection. Very good. Let's recall this with a quick activity. Okay? Yes. In case of reflection, see, when the light wave falls on the surface, it bounces back. You can observe this phenomena easily. See, this is the incident ray and on the other hand, the light is reflected back. I have made the smoke around it so that you can easily observe the path of the light. So, this phenomena you have already done, reflection. Any other phenomena that light shows? Anyone? Yes, refraction. Light also shows the phenomena of refraction. Okay, you tell me, bachcha, what is refraction? Yes, the bending of light. Light changes its path when it enters from one medium to another medium. Let's quickly recall this activity again. We have a glass slab to show this activity. Now we are observing refraction. I have taken this glass slab. It is another medium. Around it we have air. So when a light enters from air to glass, the path of the light bends, right? You can see the bending path of the light, the deviation of the light. So this is called refraction. You have already learned it. Okay, students, now tell me, do you know the rainbow pattern shown by the DVD or CD? Have you seen these rainbow patterns on the DVD or CD? Tell me, why there are such beautiful patterns on DVD or CD? Anyone? Okay, I'll tell you. These patterns are because of the phenomena called diffraction. So today we will be learning about a new phenomenon of light that it shows. It is called diffraction. So today's topic is diffraction. So after the class, you will be able to define diffraction and also you will be able to observe the diffraction pattern using simple experimental setup. So, diffraction is the bending of light waves. Is the bending of light waves around the corners of obstacle or aperture, due to which light enters. Light enters into the region of geometrical shadow. Right? This is diffraction. Let's understand the same diffraction through a simple diagram. Let us say we have a source of light and I have put an obstacle in the front of the source. Now I am making a small slit or a small aperture in front of the source of the light. What will happen? What do you think that what will happen here? The light obviously will enters puncture and enters here, and we can see the intensity on the screen. But students, we will observe that on the screen, it is not only this region where you can see the light, but the light enters into the region of geometrical shadow as well. Means these parts of the screen also will be illuminated. Do you know why it is so? Because the light ray bends here. Rather than moving in a straight path, the light ray bends, and this bending is known as diffraction. Now we will understand it through the phenomena, through the demonstration. You will be observing this demonstration through the small setup. So to observe the diffraction pattern, we have this simple setup. I have used these razor blades and I have merged it into the potatoes so that we have this steady and narrow slit. For the light, I have used this laser pattern, this laser light. Why laser light? Because it gives monochromatic light, light of single wavelength. Now students, observe on the screen. If there is no obstacle in the path of the light, you can simply see the bright spots on the screen, because light travels in a straight line. But when the same light is allowed to pass through this slit, you can see the bending of light. The light enters into the region of shadow. See the beautiful pattern on the screen, central pattern. At the center we have a bright spot, and later on we have fringes. Observe it. We have dark and bright fringes. This is called the bending of light. This is due to the bending of light around the corners of the obstacle. So students, have you noticed the beautiful phenomena of diffraction? Okay, tell me, what you observed? Yes, we observed the bright spot at the center, and then consecutively we have dark and bright fringes. Do you know why there is a bright and dark fringes in the pattern? I'll let you know. The bright fringes are due to the constructive interference of the wave. What is constructive interference? When the two waves overlap in phase, means the crest of the first wave overlaps with the crest of the another wave. Then the resultant wave will be of greater amplitude, resulting into the greater intensity of light. And on the other hand, the dark fringes is due to the overlapping of waves which are not in phase, means the one wave overlaps in such a way that the crest of one wave falls on the trough of the another wave. In this case, the resultant wave will have very low amplitude. So, we will have a dark fringe at that point. So, in this case, we will be knowing about the wave nature of the light. So, light exhibits the wave property, wave nature. Fine. Now, there must be question arising in your mind that why we need such setup to demonstrate this? Because the light has a very small wavelength. Do you know the wavelength of the light? It is in few nanometers, 400 to 700 nanometer in the visible light. So, as the wavelength of the light is very less, so we need that much of small slit, that much of narrow slit. That is why we have made a narrow slit. Fine, students. But I want to let you know about one more thing here. Do you know that this phenomena can be easily available, easily observed in sound waves? How? You can easily hear the sound of the person who is speaking in adjacent room, in the next room. Why? Because sound wave has larger wavelength and it can easily bend through the obstacles like door, like walls. So it can easily bend and we can hear the sound even if we are not in the line of sight of the sound. But we cannot observe this phenomena in case of light. We need to be in the line of sight of the light because light has small wavelength. Right, students? So I hope this phenomena is now clear to you all. So quickly have a recapitulation of this phenomena. What we observe? That the light rays bend when they are allowed to pass through the small obstacle. Right? And this bending is known as diffraction. We can observe it by using the small slit. And the size of the slit should be equivalent to the wavelength of the light. So that is why this phenomena is not easily observed in daily lives, okay? So we need to have the setup. Second thing, we must use this monochromatic source of light. Why so? Because if we use visible source, it has a number of wavelengths. It has 7 colors. So all the colors mix together and we not have the coherent pattern. Okay, students? So I hope I would be able to make it clear. Thank you so much.